Okay, so our topic is scientific notation and rounding. All right, so we'll fill that in here. Scientific notation. I have a better pen. We are, of course, period 8, and the date is the 22nd. Okay. Scientific notation or standard form involves writing any given number as a number between 1 and 10 multiplied by a power of 10. Raise your hand and show me, fist to 5, how familiar you feel you are with scientific notation. If you have never heard of such a thing, that's a 0. If you are already an expert, that's a 5, and you might be anywhere in between there. You might be a 1, a 2, a 4. Okay, I'm seeing some 3s and 4s and 2s and... Okay, excellent, excellent. So everybody feels like they have seen it at some point before. Look at this expression here. The result has the form a times 10 to the k, where 1 is less than or equal to a is less than 10, and k is an element of z. What in the world is that? Can anybody explain what that's saying? Let's break it down, all right? A times 10 to the k, that kind of looks like scientific notation, right? The a and the k would be variables, right? Okay, so we've got variables here. This part is saying that a could be greater than or equal to 1 and less than 10, so that's the number in front, and that kind of makes sense too if you think about how scientific notation looks. It could be like a number like 3.5 times 10 to a power. K is an element of z. What is z? Has anybody ever seen that before? No? Okay. Very simple. It is the set of integers. Have you ever seen the fancy R with the extra line on it? The fancy R is the set of real numbers. Z is the set of integers, okay? So those would be the positive and the negative whole numbers and also 0. So Z is a set of integers. The reason why it's important to understand this is because when you get a question in IB, they don't say write your answer in scientific notation. They say write it this way. A times 10 to the k, where 1 is less than or equal to a is less than 10, and k is an element of z. And you look at that, and it looks so unfamiliar, okay? So it's really important to make peace with this, okay? And remember that z is the set of integers. Which means that your exponent can't be like 5.7. It can't be pi. It has to be an integer. All right. Which one we'll do? We'll do one example between 1a, 1b, 2a, and 2b. Which one should we do as an example? Which one's hardest? None of them are hard? D? Okay, we'll do D. All right, so this is the scientific notation, and we're going to rewrite it. When you have a negative exponent, you're going to move your decimal backwards, okay? So you take the 5, 7, 6, you take the digits, and you're going to move your decimal backwards. It makes a very small number. When you have a negative exponent, it makes a very small number. So I'm going to go back 1 space, 2, 3, 4, 5, and make a new decimal. When I do that, how many empty spaces do I have here? I have 4 empty spaces. So a lot of times people think about the exponent telling you how many zeros to add, and that kind of works when it's a positive exponent, but when it's a negative exponent, it's always 1 less because you have this extra space right here. So it's going to be 0.0000576. 0.0000576. I'm going to go over all of these in a minute, but I wanted to give you some time to try it on your own before I go over all of them, okay? So you're doing 1A, 1B, 2A, 2B. All right, I saw some really good learning here because a lot of people were trying to figure out what that first number should be. Should it be 376? Should be 37.6, 3.76, 0.376. There's a lot of options there, right? Does anybody want to raise their hand to explain how to choose the correct one? A lot of you chose correctly. Does anybody want to explain how? All right. The reason I gave was this number that comes first has to be between 1 and 10, right? Greater than or equal to 1 and less than 10. So 376 is too big. 37.6 is too big. 3.76 is between 1 and 10. A lot of people don't think that theoretically about it. They just think find the first number that's not 0 and put the decimal after that. Okay? That works too. It's right. So here, 3.76 is what we're going for. Our decimal starts at the end of the number, so we have to figure out how many places we moved it. Did you guys get 4? Yeah? Okay, so 3.76. They write their times with an X. It's not my favorite thing because an X is also a variable, but it's fine. Sometimes I write my times with a dot instead. Times 10 to the 4th. Okay? So if you multiply 3.76 times 10 4 times, you would get this number, 37,600. These are just equivalent expressions. This one's just written in scientific notation. Does anybody want me to explain why a different answer might not be right? Some people have different answers on their paper still, and I want you to understand it if you think that it's confusing to figure out why this one's not right. Okay, next one. Again, you can look for the number that's between 1 and 10, or you can just find the first digit that's not 0 and then put the decimal after it. So it's 8.6. 1, 2, 3, 4, 5, 6. So times 10 to the 6. What did I forget? So Anne says there's a negative there. Why is there a negative? Am I making a big number or a small number? Small. A small number. So when you're making a small number, put a negative here. All right? 10 to the negative 1 is really the fraction 1/10. 10 to the negative 6 is 1 over 10 to the 6. So it's like a really small number. It's a really small fraction. So 10 to a negative number is very small. 10 to a positive number is very big. So that's the reason why we use scientific notation, because why else would we make something easy hard, right? We make something easy hard because sometimes we don't want to write all those digits. Like the number of Google, 1 with 100 zeros after it, you don't want to have to write 100 zeros. It's easier to write 1 times 10 to the 100th power. All right, next one, write as an ordinary number. So this is 10 to the positive 2. We're making a big number. So we're going to move it 2 to the right. And I get 320. You can put a decimal here, or you could not put a decimal there because it's assumed to be there if you don't put it there. Any questions on this? Okay, rounding. When rounding to a place value, you have to look at the value immediately to the right of that. So if I want to round to the hundreds place, the hundreds place is right here, it's 500. You have to look at the number after it to see if that 5 stays 5 or if it goes up. So since the number after the 5 is greater than or equal to 5, we are going to round this one up. If I were rounding to the hundreds, I'm not actually. It says to round to 2 decimal places. So that means this is what I'm rounding to, the 4. And the only question is, does it stay 4 or does it go up? So let me write the other digits real quick. 2 decimal places. 62,562.3. And then the 4 either stays 4 or it goes to 5. I have to look at the number after the 4, which is a 1. And that 1 is not greater than or equal to 5, so that means it stays a 4. I know a couple of you worked ahead on that. That's excellent. Does anybody have a question? All right, I want to give people who haven't worked ahead a moment to try the next one. It says round to 2 decimal places, which is right here. Okay? So you're going to round that number to 2 decimal places. I'm going to do a quick walk around the room, and then we're going to go over that one. All right, so for this one, we had 0.0, and we rounded this to 1 because the next digit was greater than or equal to 5. All right, significant figures. In IB, this is what we do. We round to 3 significant figures almost all the time. The only time we don't is when we're talking about money, and then for money, we talk to round to 2 decimal places, okay? But 3 sig figs all the time. So this is to write the following as 3 significant figures. So we're going to go back and see what are those, okay? Significant figures are the number of digits in a value, often a measurement, that contribute to the degree of accuracy. And we start counting significant figures at the first non-zero digit. So looking here, we would start counting the significant figures at the 5. And these are the significant figures, the 508. You still have to round after that 8. You have to look and see if this number was 5 or more, I would round the 8 up to a 9. And since it's not 5 or more, then it's just going to be 0.508. So this one, 0.508. You haven't had a ton of instruction on significant figures yet, which we call sig figs, but I still want you to try these two. Remember, the directions are find the first number that is not 0, and then count 3 digits from there. Those are your 3 sig figs.
So we don't add the 2 zeros.
All right, guys. So you were confused by this one because I did this one wrong, and I just didn't see that those zeros existed there. So you do need to actually have those zeros there. So 0, 0, and decimal point. That's kind of ugly. Let's try it again up here. 0.00508. Yeah, your number can't magically change from 5 thousandths to 5 tenths, right? 5 thousandths and 5 tenths, those are very different numbers. And so that was just a mistake on my part, and good job for those of you who realized that. These 2 zeros have to stay here, but you still start counting at the 5. So 0.00, and then you count 1, 2, 3 sig figs. So we're going to do this one the same way, okay? We have to include those 2 zeros, but they don't count as sig figs, okay? Some of you left them off. I totally know why, because I did the example wrong, but now I fixed it, so now we can fix this one. 0.00, and then 1 sig fig, 2 sig figs. The third one, does it stay 4 or does it round up? It rounds, good. All right. Are the alpacas going away? I didn't know you guys were looking out there. Okay. Questions on this one? Next one. 1 sig fig, 2 sig figs, 3. 46 points. Does the 3 stay or does it go up? It stays, right. So 46.3. Questions? Let me explain how to do this and then yes, okay? All right, so the rounding spider, you start with this number here, and this in the middle tells you how to round it, and then on the outside here is the rounded answer. So this one is weird because it says to the, oh, you can't see, sorry. This one is weird because it says to the nearest millimeter. We'll get back to that one in a minute. 2 decimal places. So you'll take this number, you'll round it to 2 decimal places and put the answer here. 2 sig figs, you take this number, round it to 2 sig figs and put the answer here. Here it's saying, how did I round this in order to get this answer? Okay? How did I round this to get to this answer? You put the rounding technique here. For the nearest millimeter, you'll have to first change the number to millimeters, and then you can round it to the nearest millimeter. Okay? So take a moment. Remember that these here are your rounding techniques, and then outside are the answers. You could do that for sure. Okay? All right. So, oh, it says, yeah, because they had a rule over here saying none could repeat, but I let you because it didn't seem like something that we would say to the 10th place. If you didn't want this to repeat, though, you could say 10th place.